There are several nonlinear effects uh, can be seen in the fiber. So usually light waves or photons transmitted through a fiber have little interaction with each other and are not changed by their passage through the fiber. There are exceptions arising from the interaction between light waves and the material transmitting them, which can affect the optical signals. These processes are normally referred to as nonlinear effects or phenomena because their strength typically depends on the square of the optical intensity. So nonlinear effects are weak at low powers, but they can become much stronger at high optical intensities. This situation can result either when the power is increased or when it is concentrated in a small area such as the core of the single mode optical fiber. You know, the core of the optical fiber may be of the order of diameter is maybe of the order of 5 to 6 micrometer. So whatever may be the power, whatever may be the small amount of power incident in the inside the core, but concentration or density of the power is very high because of the smaller area. So there are two broad categories of nonlinear effects that can be separated based on their characteristics. One is the scattering, another is the Carr effect. So scattering may be divided into several categories like stimulated Raman scattering and stimulated Bruglia scattering. And the Carr effect may have several uh, kind of uh, several classes rather. One is the self phase modulation, then cross phase modulation, four wave mixing. These are several kind of effects that can be seen inside the fiber. So this is an example what happened when we have Raman scattering. So this is the incident light and this is the sample. So this green color indicates the frequency, right? So Rayleigh scattering, it will scatter the signal in different direction with the same frequency. See, this is one is also green. But Raman scattering, we have two kind of uh, wavelengths or energy. Like anti-Stokes Raman scattering will have higher energy or higher frequency, that is indicated with the help of blue line, blue curve, right? And Stokes line in the Raman scattering, you will have lower frequency or lower energy. So it is indicated with the help of red lines. Okay, so that means for Raman scattering, the frequency or the wavelength of the signal will change. We have some higher frequency components for anti-Stokes Raman scattering and lower frequency lights, which is called the which is due to the Stokes Stokes line of the Raman scattering.